All right, it's 11 a.m. We're going to go ahead and get started. Welcome to Advanced Kentucky's online content review session for AP Computer Science A. We are joined today by Mel Hoffert from Sycamore High School. He'll be leading our session. And also Dr. Sherry McGuffin, our STEM coordinator for Advanced Kentucky. So first off, let me say thank you for all joining us. Let me continue to admit people in. And we are glad you can be here today. Hopefully it's the first of the 4 weeks that you'll be able to be here. And if you have questions, feel free to utilize the chat box. Make sure you have today's handouts. They can be accessed through the bit.ly link on the right or from our KYAP 2020 website. Mel's email is there on the screen, so if you go back to view this later on, you'll have that. This is being recorded. A couple of housekeeping items right now. Our hosts, we've got Advanced Kentucky here, our Twitter, Facebook page there, along with myself. My name is Aaron Timmons. I'm the content director for mathematics. And Dr. Sherry McGuffin, like we had already introduced earlier, STEM coordinator. So our meeting etiquettes here, your microphones are disabled. They'll be disabled the entire time. Video, please leave your video off. And we will be utilizing the chat box, so please make sure you can find that. It should be at the bottom of your screen there. And you can ask questions. We encourage you to ask questions, ask as many as possible. Dr. McGuffin and I will be moderating that chat box, and we will be letting Mel know of your questions as we go through today's session. So please, please, please use that as much as possible. If you'd like to all begin by just typing in your name and where you're from, what school you're a part of, that would be great so we can see who all is here. Also encourage you, if you have not already, to check out our website, kyap2020.com. That's where you can find all future events coming up for Advanced Kentucky, as well as other resources, both for teachers and students for all AP Math, Science, English courses. Please continue to share this information with any Kentucky high school student, teacher, parent, administrator that you know of. These are free to the public. We encourage as many people as possible to attend. So that is the all of my housekeeping. So I'm going to turn it over to Mel, and we'll be ready to go. I'm going to stop sharing my screen. And Mel, you can take over.
Okay, got it. Good. Welcome. Good to have all of you here today. And for our preliminaries, I want to share a screen with you. There's a Pear Deck that I'd like for you to join. So bear with me just a second while I do this sharing. If you can, in another tab, separate from the Zoom session, if you would join this Pear Deck, joinpd.com, and then you see the code that's there. There's some things that we're going to pull from this Pear Deck, some things that we're going to pull from the printed material that you have available. And I also have some links on this Pear Deck in case some of you don't have the printed material. It's the same links that Aaron shared with you a few minutes ago. So I will wait and make sure that you guys are able to join this Pear Deck. If you have some issues navigating that, just send out a chat or speak it out. One student in, good. How many am I expecting, Aaron?
As of now, we have 7 people total in the chat room. I think some of those are teachers, but they are highly encouraged to join as well, I imagine.
Okay. All right, so Aaron, what I'm going to do, I'm going to go ahead and continue. Joinpd.com, you can share that with anybody else that joins the room. They go to joinpd.com to get to that Pear Deck. And then this code, AFBAT, is in the upper right-hand corner.
All right, I'll go ahead and put that in the chat.
Yep, if anybody shows up late, yeah, joinpd.com, and then they just put in that join code. Okay.
Aaron, I actually already put that in there for you.
I see it. That sounds good.
Okay, super. So we'll be using this Pear Deck on also the printed materials. The reason I share a Pear Deck with you is there are some links that I want you to consider. And it's a little bit awkward in a Zoom session, in any virtual classroom session, to be able to get to links. They're not easy to click on whenever we share that. And the Pear Deck allows easy access then to some of the links that are part of our discussion for today. So you see, to prepare for this session, and maybe you already have the session guides. Hopefully you do. If you don't, you see the links there for the two topics, the two guides that will be then guiding our topic of iteration today. And go ahead and load those in a separate browser if you don't have a printed version of that. For all of you, whether you have printed version or you're looking at this electronically, make sure you have some scratch paper, some writing utensil, and then we'll be good to go. So I'm going to wait like a minute or so. You guys could give the thumbs up to Aaron when you're all set with these materials. I want to make sure that we're all on the same page. So just confirm with our moderator when you guys are good to go.
I see one thumbs up.
Yeah, my brother. So it looks like my brother. Give me a thumbs up.
All right, we've got Rose from Louisville is on. One of her students is joining.
Okay, good. Yeah, and if you're looking at these documents in electronically or digitally, if you're just looking at them in a tab, make sure you have some scratch paper. If you have hard copies, of course, you can write your responses on the document itself.
All right, I've seen no comments asking you to wait, so I guess you are good to go ahead.
Okay, awesome. Okay, this is just a brief outline of some things that we'll cover today. We're dealing with iteration, the ability to be able to repeat code, and in the form of loops. Now, you can do repetition statements of other kinds. You have recursion that allows you to repeat. And for this particular session, we're going to focus on iteration loops. And there are some fundamentals that we need to just review to make sure that you guys are good to go. Count versus event controlled. We have enhanced loops, and we also have nested loops. Aaron, are the students able to speak out or be able to chat about this? If I do just a real quick formative assessment, what's the best way to do that?
Sure, they can put all of their comments in the chat box there.
Okay,
so they can either chat directly to you privately, or they can put it out to everyone in the chat.
Okay, so let's deal with count versus event controlled. Okay, so somebody just share out. You can by chat, or if you want to speak it, or I guess chat is the way to do it. Count controlled loop. What does it mean for a loop to be count controlled? And if that's a brand new idea to you, just say so. Let's see. Okay. So someone responded, it repeats how many times the count says. Yeah, that's the right idea. In the case of a count control loop, you have a loop where you can, with mathematical certainty, you know how many iterations. An iteration is just to pass through the body of the loop. How many iterations will occur? You can determine that with mathematical certainty. Event controlled, it's kind of the converse of that, or the counter to that, you might suggest. It's where you cannot, with mathematical certainty, determine the number of iterations. you're waiting for a particular event to occur that will determine then when the loop terminates. Okay, that's going to be important for you to keep in mind when we do some tracing. We're going to dive right into, in a couple of minutes, some code tracing exercises. And it's important for you to have in your mind this whole notion about count control, event controlled. It can make a difference in the way that you process then loops. We're also going to deal with enhanced loops. Has anybody encountered, or are you familiar with an enhanced version of a loop? Maybe you've used in your code. You can just respond via chat. What type of enhanced loop maybe have you utilized? Okay, someone's saying maybe they're not sure if they have used any enhanced. Okay. Well, we're going to deal with, and maybe this will ring some bells for you, an enhanced for loop. There's a version of a for loop that has a little bit different structure, but is convenient for certain scenarios. And then we also have nested loops. What does it mean for a loop to be nested, or loops to be nested? Somebody can just share out chat-wise. Okay. Well, nested, so maybe that's a new idea for you. Nested means that you can have a loop inside of a loop. Oftentimes you'll see that when you're dealing with tabular data that's organized as a table, rows and columns, but you could have other scenarios where a nested loop might be appropriate. So we'll consider those types of loops as well. Okay, thanks for participating in the chat on that. Now you'll see in our agenda, there's a link to tracing, and I'm going to set the stage, I guess, table or stage. It depends on whether you're hungry or you want to perform. I don't know. Anyway, prepare the way for tracing. There's a link that I've given to you on this Pear Deck. So if you click on that link, it'll take you out to then a site about using trace tables. Now what you see here in this particular example is it's the programming language that's used there is not Java, but understandable enough to where you can follow it. But the idea is that when you are tracing your code, you are then keeping a table of information as the code progresses. And what you'll notice in particular about the trace table that you see that's to the right of the code that's being navigated is that when you go to the next line of code, you do not erase, you do not eliminate any values that are in your table. You just simply write new values underneath. It's important that you have, when you are tracing, that you have a complete record of what has happened and what has transpired. You also have line numbers. You can keep track of line numbers, or sometimes people will just keep track of which iteration they're on. But there is this whole notion that for each and every line, you're going to record any changes. Now, so here's the really important part. For each and every line, you're going to record any changes or any significant events that occur with regard to the variables that are part of the code that you're considering. So you see for this particular code snippet, we have two variables, one called number and one called I. And anytime some change occurs to number, we record that in the table, same with I. We also have a fourth column that's keeping track of any kind of output. And for this particular code snippet, there's some information that's being displayed to the user. In the case of Java, we would expect to see, instead of print, system out, we would expect system out print line, but the print is really performing that same function there. And we want to keep track of, is there any information that's being displayed to the user as the code progresses? So I'll just give you that as a backdrop. We're going to do some code tracing here in a second. And my expectation is that you're going to keep track of information in this tabular form. You're going to generate your own trace table. And this might be the first time that you've encountered tracing of any sort. And I want to give you an idea about how that worked. Okay, good. Any questions about this code tracing and trace table backdrop? Go ahead and chat it out if you have any. Okay, maybe no, maybe no. Okay, good. Now we're going to, and you're going to have for our session today, really three tabs of three places that you'll be going. You have your Zoom that's running, you have your Pear Deck, and maybe a third tab. Now, if you have a hard copy of the session materials, then you can go to that. But if you have an electronic version of the session materials, then looks something like this. So whether you're looking at this hard copy or whether you're looking at this in electronic form, we're going to skip past some of the early sections of this document, and we're going to go right to the looping parts. Okay, so we get this hand tracing code. We've talked about that. I've given you the backdrop with regard to tracing the code. Repetition, I mentioned to you that there are two ways that you can repeat blocks of code. You can use looping or iteration. You can also use recursion. And then we have loops are fun. Well, they certainly are, yeah. I mean, who doesn't enjoy writing loops? But there are a variety of loops that are fair game from a College Board standpoint, and the College Board expects you to understand these certain types of loops that are available in Java. The while loop, and on that first bullet point, it is suggesting to us that often while loops are used for event-controlled scenarios. The very first question I asked you was count controlled versus event controlled, and often while loops are used for event controlled. When you don't know how many times the loop will iterate, often you'll use a while loop. Could you implement a while loop in a count controlled way? You could, but often while loops are used for event controlled scenarios. We also have for loops. For loops are often used, although not exclusively so, they're often used for count-controlled scenarios. When you know how many iterations, you can determine with mathematical certainty how many iterations will be a part of your loop. Often a for loop is used. Does that mean that you can't implement a for loop in an event-controlled way? You could, but often not the case. And these are not hard and fast. They're just kind of general guidelines, or maybe you could even just say observations that are made as coders develop their code. Typically, while loops for event-controlled scenarios, for loops for count-controlled. We also have an enhanced version of for that we're going to take a look at called the for each. Now, that particular loop is handy when you have a data structure like an array or maybe an array list, and you want to touch or traverse that entire structure from beginning to end, and you want to process each and every element in the order that it is organized in that structure. If you want to start from the very beginning and you want to touch each and every element in an array or an array list from beginning to end, then often an enhanced for loop is a good one for you. But we'll see, or hopefully we'll have time to look at scenarios where you might be processing an array and array list, and maybe you don't need to process every single element. And for those particular scenarios, an enhanced for loop can be a tedious and cumbersome construct to use. So you just have to use some wisdom, and something that comes with practice, but you have to use then these types of loops in the appropriate way for certain settings. Here we go. We have examples of the 3 different loops that we discussed: a while loop. It has a Boolean expression that controls it. We don't have, like we have in the case of the for loop, we don't have the loop header broken up into 3 parts. We just simply have the Boolean expression. And as we know from Java, the loop iterates as long as the Boolean expression is true. Once it's false, then the loop is done. The for loop, its loop header has 3 parts. You have the initialization. So you can put in this section any and all variables that you intend to use that will control the loop. You then, separated by a semicolon, you have the Boolean expression, the loop condition, we call it. It is a Boolean expression that's controlling then the loop. As long as this Boolean expression is true, the loop iterates. And then of course we have the update. As you guys know, plus plus just simply adds 1 to a variable. And in that update, remember, you should have encountered a for loop at this point, but in case you haven't, or maybe you've forgotten, in the case of the update, the I++ that we see here, that happens at the very bottom of the loop. Very bottom of the body of the loop. The body of the loop is everything that's in between the curly braces. So before the I++ is executed, everything in the body would need to be executed first. And then at the very bottom of the loop, you can almost think of this as a separate statement that's at the very bottom of the loop. It will then add 1 to that variable. Then it will come back up and check then the condition to see if it's still true, to see if it has permission to iterate once again. You can think of the condition like a gatekeeper. As long as it's true, you have permission to enter the body of the loop 1 more time. So this update can happen multiple times at the bottom of the loop. In case of the initialization, it only happens once before the loop even starts, okay? And then we have the enhanced for loop, looks like this. So here we have, it's a little bit different structure. We don't have this broken up into 3 parts like we have with the traditional for. But instead, we can, in the for loop, we can give it then some collection. Okay, I'm going to use the general Java term, collection. Collection just simply means that you have a grouping of information. So it could be something like an array, or it could be an array list, or it could be some other kind of, there are a variety of other collections that are available in Java. But array and array list are those are the collections that should be most familiar to you. On the enhanced for, you mentioned the name of the collection. In this case, we're told by way of the comments that numbers happens to be an array of ints. Okay, cool. That's important to know, the type of data that's stored in that collection. That's going to make a difference as far as how we then construct this particular enhanced for loop. So we have the name of our collection on the right-hand side. And then on the other side of the colon, that's a colon that's there. Semicolons and colons are sometimes hard to distinguish. So then to the left of the colon, we have then the type of data that's stored in that collection. And then we have this loop variable. And you can give it whatever name you want. It makes sense to give it a name that fits then the information that's being provided. And then here's the magic of the enhanced for loop is that it takes care of and determines behind the scenes how many elements are in the collection. And it will iterate that many times. So however many elements are in the collection, that's how many iterations will occur. So for example, in this case, value, the very first time through the loop, will assume the value for the first element in the collection called numbers. So let's say numbers happen to be an array that had 2, 4, 6, 8. Who do we appreciate? Okay, 2, 4, 6, 8 had those 4 values in it. The very first iteration through the enhanced for loop value would have a value of 2. Then we would add that to our total. The enhanced for loop takes care of determining whether there are more. If there are more, then it will iterate another time. Well, if we have 2, 4, 6, 8, of course, we can iterate again. Value second time through would assume a value of 4, third time 6, fourth time 8, and then the loop is done. And it all happens very seamlessly. We don't have this setup of the initializing values, updating certain variables that are controlling the loop. It all happens very seamlessly for us. So in the case of a collection where you need to process it from beginning to end and every single element, it is really the better way to go because it's less prone to error. You could do that same sort of thing, this same scenario with a traditional for loop, but there are errors that could be introduced. Okay, so that's the enhanced for. Any question about those 3 types of loops, the detail of those 3 types of loop before we start looking at some code snippets and you start tracing? I'll pause for a few seconds, give you a chance to digest. Okay, any point in time, just chat away. If you need to, if we need to regress or you have any questions, just let me know. Okay, now we're gonna do some tracing exercises. Here we go. We have this code snippet. This is a while loop. And we have these 2 variables that we're considering. Now, what I want you to do is, in addition to answering the question, now there are 2, actually, just one, in this case, one fundamental question that we need answered, but 2 values that we're concerned about. We want to know what are the values, ultimately, what are the values of num1 and num2? We want to know what are the values of those variables after the loop is done. And I want more than just those numbers. I want to see the tracing, the code tracing table that allowed you to arrive at that outcome. Okay, so go ahead and work on this first example. And let me go back and remind you of what the tracing table looks like. You keeping track of line numbers or the number of iterations, you can think of that, or number of lines that are being executed. You're also keeping track of your 2 variables. And we don't have anything that's being output in this particular example. So I would just expect then 3 3 columns in your trace table. When you are done with this first exercise, just let the moderator know. A thumbs up, maybe, or just say, okay. If there are some questions, you're having issues tracing this, then let me know. Can be, yeah. So somebody's asked the question, and I see some students that will even on this example. And I kind of left that as an open issue to see how you guys might deal with that. But the question is asked about this part of the code snippet. We have this this expression here that needs to be evaluated in order to determine whether our loop can iterate or not. And what else I often see with students is they'll add another column that then gives them that value for that expression evaluated. And oftentimes I'll do that as well, especially if you get an expression, have an expression, and this one's not particularly complex, but still there's the value in having that as a separate column. But especially if the expression becomes more complex, there's value in having then that as a separate column in your trace table. And it can make it easier then for you to process and then answer the larger question of, do I continue to iterate or not? Being able to evaluate the entire Boolean expression that's there. So that's a good suggestion. So feel free to add that. And look, guys, on these tracing tables, here's the bottom line. You need to, and we're working through a few examples so you can kind of begin to hone your skills. Maybe this is the first time you've ever encountered this. But you need to figure out what your code tracing technique is going to be. Are you going to, like in this case, are you going to have then each and every line number? Is that going to be a column that you're going to consider? Are you in your, in your trace table, are you going to have certain expressions that appear? So it's really figuring out what is the best approach and the best technique for you to trace. But the bottom line is, regardless of how you flavor this, how you personalize this, the data is going to be represented in some tabular way for you to be able to process it and then make a determination. Anybody need more time for this particular loop? Okay. Let's see, what's the best way for me to share this without seeing? I was about ready to skip over to Well, let's do this. Let's go through. I'm gonna. There's a way I can share this without revealing. I'm gonna pause my sharing for a second. Hang on. While I do a little hocus pocus here. Okay. See if I can find that snapshot I just took. I got like way too many windows here. Here it is. Okay. There's a screenshot of, for the first example. Can you guys see that? I don't know if I can zoom that or not. And this is one that was given to me by NIMSI. You see in this particular case, they don't have a column for the division that it's occurring in or for the line numbering. Maybe you have that there. They just simply have the two variables that are involved with that.
I think you're still paused, Mel.
Oh, I am. Whoops, resume share. Whoops, faux pas. How about now? Can you see that little bitty table?
We're good, it's just small.
Oh, let me see. So zooming this. Now?
There we go, that's good.
Okay. So here we have an example that where you just see the two variables and how their values are progressing through the loop. You don't erase any of the values that are there. And you just keep track of then how they've changed. So your tracing table may look a little bit different from this one, but you would be able to answer then, ultimately answer that question about num1 and num2. Any issues with this one? Or we try some others. Okay. Let's go to, I'm going to skip. Let me find another loop example that's in here. There's some recursion. Okay, here we go. Let's skip down to number 4. Okay, so it looks like this. So let's trace this code. We have one variable called k. Happens to be a while loop in this case. And you might want to have an additional column for this modulus. Do we need to do a refresh on modulus, or everybody good to go? Just send by the way of chat if we need to do a review on the modulus operator, what that does. It's kind of all over the map whenever I visit with students across the country. Some have this modulus thing down cold and some don't. Just to remind you, it's sometimes called the remainder operator.
You can do a thumbs up if you want to, or if not, then.
Okay.
I don't think I've seen thumbs ups. Thumbs up.
Good on that. Okay. Okay, awesome. Okay, good. So you might want to have a separate column for the modulus. That might be enlightening. It's a little bit more involved kind of arithmetic that's happening there. So trace that. And make sure you have a column for output. Like we had with this tracing example, You want to make sure that you're keeping track of the output as well as then the variable, and you might want to have an additional column for that expression where you are calculating the modulus. So I'm going to turn you loose on that one. Whoops, there, that one. Okay. And once you process that one, just a thumbs up to indicate that you're good to go on that one. Just so you know, timing wise, we, what are we? It's like 20 till already. Wow. Time flies when you're having fun, guys.
You've got about 15 minutes here remaining.
Okay. Okay. We're going to do, we'll take a look at this one and maybe a couple of, there are some multiple choice examples in your packet. Maybe we'll look at one or two of those. And there's an additional packet algorithm practice where we'll talk about some of the common algorithms that you can expect that the College Board will, like, I'll put it this way, that the College Board expects you to know. And many of them involve loops. So we'll at least have a chance to do a quick flyby of that particular document and look at some code snippets there. So are we waiting on anyone? What's the response there, Sherry? Are we
I think you're good to go.
we're good to go on that one. Okay, good. All right, so for this particular code snippet, we would expect then a trace table that looks like something like this. And you could have output as a column. They happen to, in this case, this packet given to me by NIMSI, they happen to have the output just going off to the right. I think that's probably because they were literal in this particular code snippet they were looking at. It was doing a print. And you guys know when you do a print, it takes whatever information you give to it and it just puts it to the right of what's already there. It doesn't go to a new line.
Mm-hmm.
But they were very literally then in their tracing, giving us then what that output would look like.
Do you want to share that? We can't see that on our screen.
I did that again. I paused my share so I could
There we go.
to that.
Thank you. Uh-huh.
Oh my goodness. Yeah. So something like that is what you would expect for your tracing. Anything unexpected And if you think about what's interesting about this particular code snippet, this modulus that we're using here is asking an interesting question. It's looking for numbers that are 1 greater than multiples of 3. So any number that you could think of that's within our range that is 1 greater than a multiple of 3, we would expect to be revealed to the user, be printed, be displayed. And that is in fact what we get. Sometimes that helps when you're looking at your output. If you think about what is the intent of the code, it can help you then when you're processing the output. Any questions about that?
Good question, clarification maybe.
Yep.
These are used in a lot of multiple choice questions. Suggestions, like quick suggestions on how you can use code tracing for free responses as well?
Well, in the case of free response, it might be the way you would use it for free response, you would use it then to check your code. Once you have it in place, then to go through and actually trace it. Because here we go, guys, let's just be real about this. That's a brilliant question. When you're in the multiple choice environment, you're forced to trace. I mean, it's a survival skill. In the free response environment, you just dump code out, and then human nature, and I see it with my students all the time, they dump that code on their page and they think they're some kind of superhero, I guess because their mama told them that they are. They think that they're infallible and that their code is perfect in every way, and then they move on to the next thing. So it's essential and I should have predicated our discussion, our session on this. It's essential in the free response environment that you do not get lax, that you do not get in this superhero mode, that you test your code once you have it in place, have some set of data, run it through its paces, trace the code as we're doing here to make sure it really does what it should do. Because you can run into scenarios of some of the common mistakes. I mentioned one here, off by 1. That could be a devastating error. And from the College Board rubric on free response, you could take a severe hit for being off by 1. Off by 1 means that in your loop, maybe you didn't go far enough, or maybe you went too far, or maybe you didn't start soon enough. I mean, there's all kinds of off by 1 kind of errors that can occur, but there are other kind of common errors that can occur as well besides off by 1, but that's the most common one. And if you don't trace your code and you think you're some kind of superhero, you know, I got a website for you, goodluck.com. You need to trace your code even in the free response environment. Any other questions related to that? Okay, so where are we? We have how many minutes? Crap, we only have about 5 minutes. Is that right, Aaron?
Yes, correct.
Okay, so what I'm going to do, maybe I'm going to leave some of the other tracing examples that are here just to practice. Now look, guys, you don't have a multiple choice exam, but you can do these code snippets just to practice your code tracing technique so that when you're on your free response, you've got a go-to unplugged technique for tracing your code. Okay, so there's some other multiple choice examples for you there. Okay, we're going to switch gears now. And we're going to move over to this. Close that one. We're going to move over to this document called Algorithm Practice. Now that you have the whole notion of different types of loops, those tools in your toolbox that you can utilize, the while loop, the for loop, the enhanced for, then you need to think about an enhanced set of tools. So fine, you know about the different types of loop, while for and enhanced for. You have screwdrivers in your toolbox. But now we could talk about common algorithms, maybe that you can add to your toolbox as well. So not only would you have a screwdriver, but maybe then you have a power drill. All right, some kind of, you can think of it that way metaphorically, just kind of a layered kind of and more powerful tools that you can utilize. And in this particular packet, we get an overview of common algorithms that really can help. If you have a notion about these algorithms, have these in your toolkit so that when you're doing the free response, they can be go-to bits of code that you can utilize. Traversing an array, oftentimes dealing with arrays or collections, the College Board might ask you to count to some, maybe print, maybe modify some elements, maybe find max or min, maybe find the index of a max or min. Inserting into an array and deleting an array, those are also very common. And you'll find that on most free response questions that deal with collections, you will have one or more of these kind of concepts that'll be utilized by the College Board. They'll expect you to have an understanding about these common algorithms. Okay, so let's take an example of this. So number 3, where we're trying to maybe loop through a particular collection. In this case, it happens to be a string. So you need to think of strings in a collection kind of way. String is just a collection of characters. And so for number 3, how would we then loop through an array to see loop through a string, which is essentially a collection or array of characters. How do we loop through the string in order to make a determination about whether a 0 appears there or not? And you would have to use a loop to do that. So I'm just going to turn you guys loose for a couple of minutes, see what you can come up with code-wise for that one. Number 3. And I'm going to give you guys go ahead and work on 3, kind of your loop version of that, because you can, I'm going to give you a little heads up on that, a little tip. For number 3, you could actually do that in a non-looping way. But when we get to 4, where we build on this idea of does it have a 0 and then how many are there, a loop becomes necessary. So I was really just kind of laying the groundwork for 3 and 4 really kind of go hand in hand. So I'd be curious to see what your looping version of that looks like, where you're looping through and trying to determine if there is a 0. And when you have something in place, just let me know, or actually I may have to more yield to the time. What do we have, a minute or 2, Aaron?
Correct.
Okay. Okay, while you're looking at 3 and 4, I'm just going to go ahead and do the reveal on this. And let me zoom. So to take this string and to loop through it one character at a time, you're going to use then a for loop that's structured this way. That's one potential solution, and then substring. And then you're going to check to see if you find a 0. Now for number 3, we were simply trying to determine if there were any zeros at all. You could have just used indexed of. Okay, fine. But to take that idea and now build on it for 4 to say, okay, I found a 0. Now how many of them do I have? You really must have a loop to do that, to process that. And a for loop is the way that you can do that. You could do, there could be, potentially you could do an enhanced for version of this as well. That could work. And then of course, once you've worked your way through the entire loop, then you just return that count. There are other common algorithms dealing with max and min as well that are outlined in this document. If your teacher, or if you need the answers of the keys to this, I'm sorry, the answers to any of these, just let me know. Or if you need some further guidance, then you can just contact me. Aaron has given you then my email address, but I'll bring it up here again on the slides. There are some other examples that maybe we could have gone through if we had time, but Hoffert M at Sycamore Schools, you guys just send me an email if you need some further assistance with loops, some more examples. Use the AP Classroom to help you. AP Central also has samples or examples. For doing code snippet work, CodingBat, Rex Tester is good. And then again, here's my contact information. And we're probably fresh out of time, huh, Aaron?
All right, yeah, Mel, we are right up against it. So again, let me thank you. Let me share one more screen. It's got that information on there as well, but let me show you one more thing. So again, thanks to Mel Hoffert from Sycamore High School for leading our review session today. Contact information for all of us, Dr. McGuffin, myself, as well as Mel, can be found on the slide in front of you, along with links to our KYAP 2020 website, as well as the handouts. Like Mel said, if you are a teacher and you would like solutions to the handouts shared today, please contact him, or you can email either of us as well. Next week, we will be here at the same time. Mel will be back with us working through Unit 5 of the CED, which I think is writing classes. Yes. So please tell a friend, tell a teacher, tell a parent, join us. You know, as you can see, Mel wants to build in as much engagement as possible. So the more students we have participating, the more questions we can get asked and build a greater sense of community. So any other closing remarks from you, Sherry or Mel? If not, we will sign off.
Where will the video of this will be available? Is it going to be pushed out as an email, or how will they get to it?
Good question. Our first session this morning is already on our KYAP 2020 website. So as soon as the video is processed, then we will get that up on the KYAP 2020 website as well.
Okay, super.
Thank you so much, Mel. You've been very, very helpful. And I know that Kentucky's teachers and students will appreciate it very much.
Maybe once the participants leaves, will we have a time for a debrief?
Yeah, I'll conference call us in after this.
Okay, super. Okay, awesome. Thanks for stopping by, guys. See you next week.
Thanks, everyone.
Okay, bye now.